It's, I think, Corbett. All right, here we go. So remember when we learned how to graph linear inequalities, because we've already done this, we said that you should always make sure that the inequality is written in what form? And I'm going to write it kind of like it. I'm going to put an equal sign here. Just, I know that's not an inequality, but what is this form called? No. Slope intercept form. So we want to make sure that our inequality is written in slope intercept form. So the only difference between the y equals mx plus b is that this equal sign is going to be replaced with either a greater than or a less than or a greater than equal to or a less than equal to. Okay, that's the only difference. We need to determine if the line is, think about when we graphed linear inequalities, we have to determine if the line is going to be solid or dashed. So let's talk about what makes the line solid. It is equal to, so it has the greater than equal to sign or the less than equal to sign. That's what a solid line is. If it's dashed, that means it's just going to be the greater than symbol or the less than symbol. And here's how I think about that. The reason I'm dashing the line is because the numbers that lie on the line aren't included. That's why it's not equal to. Okay. And then, do you guys remember how to shade? What was the rule? We shade above or below. Brody, was that you? Good job. We shade above the line or below the line. So let's talk about when we shade above the line. What symbol makes us shade above the line? Greater than or greater than equal to. What symbol makes us shade below the line? Less than or less than equal to. Okay. So the first example that we're going to do, example A, is this written in slope intercept form? Okay. So someone tell me how to put this in y equals mx plus b form. Subtract 3x from both sides. So that gives me negative y is less than negative 3x plus 2. What's the next step? By negative 1. Uh-oh. So what's the rule? There's a special rule about that. What is it, Gav? You flip the inequality whenever you multiply or divide by a negative. Yes. Like this? Okay, yeah. So you flip the inequality whenever you multiply or divide, that says div, by a negative. So instead of this being less than, it's now going to be y is greater than. My negative y divided by negative 1 turns into a positive y. Negative 3x divided by negative 1 turns into a positive 3x. And positive 2 divided by negative 1 is negative 2. So how do I graph this? I forgot. What to
Negative 2 on the y-axis.
So begin at negative 2 on the y.
And then go
Up 3 over 1. Good job, sir. Up 3 over 1. Is my graph going to have a solid line or a dashed line? So I'm going to connect these points with a dashed line. So remember, we begin at the y-intercept, negative 2, turned my slope 3 into a fraction. Okay, Brody, are we going to shade above or are we going to shade below our line? Yeah. We're going to a below. Look at what we ended up with. It's above. Good job. So we're shading right here. This is above the line. So what if, let's just say that I wasn't sure that was right. Could I check it? How? Pick a point in the shaded area. How about if I pick the point -1, +1? Is that okay? Okay, so let's write down this test point. My test point is going to be -1, 1. What do I do with that test point, Antoine? Plug it into the original. Put it into the original. In case you made a mistake, right? You want to put it into the original, the equation or the inequality that you didn't do any manipulating to. So I have 3x minus y is less than 2. I'm going to plug in -1 for x. So 3 times -1 minus y is 1. And it better be less than 2. If we graph this right? So what is 3 times -1? And -1. What is -3 minus 1? It's -4. Is -4 less than 2? It is. The other thing that you could do is you could pick a point that's not in your solution set. So if I picked a point that wasn't in the shaded region, what should happen? I should get a statement that's false. Okay. Do you guys remember that? Kind of. Okay. Let's do the next one. I have to solve this for y. So how am I going to get y all by itself? So subtract 2x from both sides. So 3y is greater than or equal to -2x plus 18. What would you like to do now? Divide every single term by 3. So I'm going to kind of shift down here. So 3y divided by 3 gives me y greater than or equal to -2x divided by 3 is just -2/3 x. That represents my slope. God bless you. And a +18 divided by 3 is 6. So where am I going to begin? And what is my slope? I heard someone say where I began. Say it again. 6. Begin at 6 on the y-axis. And what's my slope? So that means I'm going to go down and to the right because we always run to the right. So 1, 2, 3. Begin at +6 down 2/3. Whoops. Solid line or dashed line? Solid. Shading above it or shading below it? Above. Good job. I want to check this, and I'm going to pick a point that is not in the solution set. And I'm actually going to pick like my favorite point, which is 0, 0. So I'm going to test the point 0, 0. If I plug that into my inequality, am I going to get a true statement or a false statement? Because why? Because it's not in the shaded area. Okay, so let's check that. 2 times, let's see, x is 0, plus 3 times y, which is 0, has to be greater than or equal to 18. 2 times 0 is, plus 3 times 0 is 0 ever greater than or equal to 18? So that means that this is false, and that makes sense because it's not in the test region. It's not in the shaded zone, okay? I have a question. What if I chose the point, let's see, 1, 2, 3, 4, 1, 2, 3. Yeah. What if I chose the 0.62? If I chose the 0.62, is that going to be in the solution set or not? Who said that? Who said yes?
Yeah.
Why? Why is it going to be in the solution set, Corbett? Is the 0.62 in the shaded area? I need to check because you think so? 1, 2, 3, 4, 5, 6. 1, 2. Where is it? I'm trying to get my pen to change. It's right on the line. It is right on the line. Is our line solid or dashed? Our line is solid. So that point does work because it's right on the line, and that means it includes points on the line. It wouldn't work. Yeah, great, great, great. Are we good with this? Okay. Yeah, I don't blame you. Okay, let's do another one. Can you guys solve this? Yeah, I can. Yep. So example C. What do you guys think? You got to do what for it first? Subtract 12 from both sides. Okay. So 3y is less than or equal to 4x minus 12. What next, Dakota? Divide everything by 3. So y is less than or equal to 4/3. That's my slope. X minus 4. I'm going to begin at -4 on the y-axis, and then I'm going to count a slope of 4/3. So up 4 to the right 3. Is my line going to be solid or dashed? Good job. So there's my solid line. Am I going to shade above or below? Below. Okay. Do we need to choose a test point, or do you guys feel good about this? Okay. So we're going to look at this graphed inequality. It says the blue, like we're going to write the inequality for the blue shaded region. So this is really the region that's shaded. I know it's not blue on any of our paper because I didn't print these in color. But what would we need? Like, what kind of information would we need if we were going to write an inequality for this? What are some things that we needed to know? So, so this is we're going to write the original equation. So what are some things that we need to know to write the original equation? Brody, go back to what you said. Greater than or equal to. So we are looking at this line, and because this line is solid, that means that I'm either using the greater than equal to symbol or the less than equal to symbol. Which symbol am I using and why? Okay, so I know I'm going to use the greater than symbol because it's above the line, and it's because it's a solid line, I know that it's going to be greater than or equal to. So I can already start off with y is greater than or equal to. What else do I need? Well, the points are right there. What do I need to write this equation? I need to know what b is and what else? M. Yeah, I need to know b and m. So can someone tell me what the y-intercept is? It's 4. And what is your slope? It's -4/4. And what does -4/4 reduce to? Very good. So that's going to look like negative x, because I'm not putting the 1 in front of it. We haven't been doing that. Negative x plus 4. This is the inequality that represents that graph. Okay, we're not doing that word problem because it's a bad problem, but I think you have a word problem in your homework, but let me look. What? Yeah, but he's not here. He'll be fine. We'll do the word problem that's in your homework. You're in it, yes. Which one is it? Okay. So we're doing you. So you guys are going to do all of the graphing, but I'll do the word problem with you. Is that okay? All right. No, I'm not going to do number 10 as well. You're pushing your luck. Shh. Okay, that's fine. Do you want to do that? Okay. Here we go. Gavin went to the movies. This is the word problem from your homework. We don't know which Gavin, just a Gavin. Okay. Shh. A Gavin went to the movies and he purchased a ticket for $8. He also wants what? Snacks, which cost what? $2.50 each. How many snacks can Gavin purchase if he plans on spending no more than? So what symbol is that? Let's think about what this means. This means that the total can be no more than. What does that mean? Less than or equal to. Good job. So the total has to be less than or equal to the cost of a ticket plus his specific number of snacks. So we're trying to figure out how many snacks he could potentially buy, right? So, or write an inequality for that. And we know, so let's first of all start with writing an inequality. We're going to kind of not think about how much money he has. If I just wrote this as y equals mx plus b. Go ahead. Yes, 15. Yes. It's less than or equal to, but yes. 250x. Good job. That's so awesome. So if we were thinking about really this is in y is less than or equal to mx plus b, right? Remember that the initial value, what you pay for up front, the word each or per is your slope, and y is representing the total. So if we started with an equation and we used a y, that's okay, but we know that the total is 15. Could we solve this to figure out how many snacks he could buy? How? How do you know that? I'm going to stop you for 1 second. How do you know he had $7 left? Oh, so you subtracted 8 from both sides in your brain? Okay. Keep going. Okay. Yeah. If you buy 3 snacks, you're going to have 50 cents in the hole. So you're going to be doing dishes or cleaning up the theater afterwards or something, right? So how many snacks can he buy? No more than 2. I know you didn't. I know that you just did it in your brain, and that's fine. But sometimes you have to be able to show it. But you're exactly right the way that you did that. Okay. How would we have solved this? What did Dakota really do in his brain? He divided both sides by 2.5. What is 7 divided by 2.5? Can you just go up to the counter and say, hey, look, I got 15 bucks. I need a ticket and I want 3 snacks, but I really can't afford it. So just dump some of those jujubes on the floor and give me the rest of it, or those Raisinets or whatever. Does that work? Or spill half the popcorn, right? That doesn't work, right? Okay. So you guys are doing 10 questions. You are graphing them. You have 10 questions. There is zero reason for you to not finish this. Zero. Yes, you can listen to music. Yes,